This is a tutorial on solving quadratic equations by factoring. The ultimate goal of today's tutorial is to find the x-intercepts, and as you can see, there's three different methods you can do that. You can either graph, you can factor, or you can use the quadratic formula. Now the quadratic formula, let's leave that for a different tutorial. We've learned about graphing in the past, and we're just going to review it really quickly. So I need an equation first. And in order to graph, I need the vertex. And that's going to be my h and my k value. We always take the opposite of the h, and then we put the exact same value as your k. So that's our vertex right there. I also know that from this a value, since it's a negative, it's going to give me a maximum. So I'm just going to sketch this really quick. My x and y axes. And then maybe that's 4 and this is 6. And our vertex right there. Okay, so since this is just a sketch, I'm just doing this on the fly, I'm just going to draw it pointing downwards. I know it's not that accurate, but that's okay. Okay, and I can quickly see where my x-intercepts are. And I don't know, maybe this is 0 and this is, say, 7. I would easily say, well, my x-intercepts are 0 and 7. Okay, so again, that's just a really quick review of graphing, but that's not really what I want to focus on in this tutorial. What I want to focus on is factoring. Okay, so here's an example of using factoring to figure out your x-intercepts. As you can see, the very first question asks you to solve this simple trinomial. Now, it's no longer a simple trinomial that we're used to. It's actually an equation. It's not an expression. And we see that because of the equals 0 at the back. We've never had that there before. So this is going to allow us to actually figure out what x equals to. In other words, solve. In order to do this, we're going to factor. And since it's a simple trinomial, I know I can put it right away into the brackets. Remember that equals 0 at the back. It's very important. Okay, so x and x go in front. They have to make the x squared. Two numbers that multiply to 12 and add to 7, I'm thinking positive 3 and positive 4. Okay, so both of those numbers multiply to 12 and add to 7. Okay, now we've done this part before when we were factoring, but we've never actually solved before. And here's the logic behind the solving. There are two brackets, two sets of brackets here, which means that they're multiplying each other. And these two numbers have to multiply to give you a 0. There's only one way that two numbers can multiply together to give you a 0, and that's if this bracket equals to 0. So when you times it by a number, it should equal to 0. Or what if the other one was the 0 and this one was the number? So when you multiplied it, that should equal to 0. We're actually going to have two cases. So let's just try it out. What if x plus 3 was the one that equals to 0? And what we do is we just solve. Bring the 3 to the other side. X equals negative 3. Okay, and why don't we just check to make sure that this actually makes sense? Well, if you're telling me x is negative 3, let's get rid of those x's and put negative 3's instead. Doesn't that make this one equal to 0? And this one equal to a number, so 1. And when I multiply those, I get 0. So in that case, this x-intercept makes sense. So when you have x is negative 3, your y value is going to be 0. Okay, let's solve for our other case. What if x plus 4 was actually the one that equals to 0? We do the exact same thing. Bring the 4 over. You get negative 4. Okay, so again, I'm just going to replace the x's with negative 4. and negative 4. And when I do that, this first bracket becomes a number, negative 1. But the second bracket is the one that equals to 0 because we forced it to do that. And when I multiply these two things together, I get my 0, which means this is the correct answer. Okay, so therefore, my x-intercepts are negative 3 and negative 4. Okay, let's try another example. Taking a look at the second one. This is not a simple trinomial. This is actually not even a trinomial. This is a binomial. And looking at the binomial, well, I'm going to start factoring by factoring out the greatest common factor. So that looks like they can both give up an x. Don't forget that equals 0. Again, it's very important. So if I divide this one by x, I'm just going to be left with 3x. And then dividing the second term by x, I'm going to be left with positive 5. So there we go, we're done our factoring. And we're going to do our two cases. So here's our first case and our second case. And again, I want that to equal to 0. Let's look at our first case. If x was the one that equals to 0, well, there's really no solving. I mean, x is already 0. So that was pretty easy. Let's do the next one. If 3x plus 5 is equal to 0, well then let's solve for x. There's a couple things attached to it. We'll bring over the one that's least attached to it, so the one that's a little bit further away first. You get 3x equals negative 5, and then let's get rid of that 3. Divide both sides by 3, negative 5 over 3. Okay, so there you go. There are two x-intercepts again. So therefore, your x-intercepts are 0 and negative 5 over 3. Okay, now there is actually an easier way. You don't have to do all of this work if you don't want to. Okay, it's actually quite easy. If you take a look at the brackets, if you just do the opposite of this number, you get your numerator. And then you just take this number and you put it as your denominator. So as you do more and more examples, you're actually going to be able to figure out easier ways to do this. But what I'm going to do now is I'm going to be a little bit mean and I'm going to throw a fraction at you. Okay, so I want you to solve this equation. In other words, I want to know what the x-intercepts are. Okay, so the very first thing we're going to do is, again, I can't have this negative 2 here. It has to equal to 0. That's the only way that it'll work. Let's bring that over to the other side, and then the right-hand side will be 0. So x squared over 6 minus 4x over 3 plus 2 is equal to 0. Okay, so we get the 0 on the other side, which is what we really want. Now what I don't want is I have a whole bunch of fractions, and fractions are kind of ugly. So let's get rid of the fractions. One way that we can do that is if I multiply both sides by a common denominator. So we have a common denominator, sorry, just a regular denominator of 6, of 3, and this one has a denominator of 1. So I'm thinking common denominator, probably 6. I'm going to multiply the whole left-hand side by 6. And I'm going to do the same to the other side because we have to balance. Your equation has to be in balance. You can't just multiply 6 to one side. All right? If we multiply the entire left-hand side by 6, we're going to get 6x squared over 6. Now it's still a 6 on the bottom, not a 36, because remember, this has a denominator of 1. It's just 6 over 1. Okay? Minus 24x over 3. Okay? Plus 12 over 1. And that's going to be equal to 6 times 0 is just 0. All right? Now you're going to tell me, well, that didn't get rid of the denominators at all. if you break them down, 6 over 6, that's just x squared. Minus 24 over 3, that's just 8x. Plus 12 over 1, that's just 12. So perfect. No more fractions. That's fantastic. Okay, and this is just our very first question that we did, the one that we did on the previous slide. Okay, let's just factor one more time. Okay, again, equals 0 at the back. X and x in front to make that x squared. Two numbers that multiply to 12 add to negative 8. Let me see. So how about negative 2 and negative 6? Those two add to negative 8, and they multiply to positive 12. Great, I got them. Okay, perfect. Now, why don't we try to jump some steps now that we're pretty much experts? I'm not going to do all that work that I did in the previous slide. I'm actually just going to solve it. So, therefore, my x-intercepts are positive 2 and positive 6. So again, why don't we write the one step that we didn't write above this? We know that from this case, x is going to be the opposite of what's in the bracket. And in this case, x is going to be the opposite of this one. So there we go. We get our two answers. And again, you don't have to show the steps in between. Let's make this even more complicated. I know you guys don't want to, but I'm going to do it anyway. Let's make a word problem. So this is the last question. Number 3, a picture that measures 10 centimeters by 5 centimeters. So here we go. I'm just going to go, here's a picture. Okay. So that's supposed to be a happy face, but anyways. All right, and you got a 10 centimeters by 5 centimeters. And it's surrounded by a mat. Now, a mat is just, it's actually this white piece of paper thing. And it makes your picture look a lot bigger because it's probably pretty small in the frame. So this is just like a piece of paper that frames your picture. The width of the mat is the same on all sides. In other words, it has a uniform width. Okay, so we'll say x from here all the way to here. We'll say x as well, and it's the same everywhere. Okay, x and x. So the exact same width all the way around. Here's where we start making our equation. So they've given us a hint now. The area of the mat. So area of mat. I'm going to start creating my equation. Is equals twice the area of the picture. So 2 times the area of the picture. We're basically decoding, and you want to know what the width is. In other words, what is x? Okay, so you're solving for an x-intercept, or you're solving for x. Okay, so let's start creating our equation. We already know what the area of the picture is. This area right here, isn't that just 10 times 5? So we have 10 times 5, that's the area of our picture. And I'm just going to transfer that 2 down in front. Equals area of the mat. Now that's a little bit trickier. Okay, so what we're going to do is we're going to say, well, this is 10 centimeters right here. So from here to here, that's 10. All right, and you know that since this is x, then this must be x. And since this width is x, that one must also be x. I think it's safe to say that, well, why don't we get rid of this top part, and we'll just say that the entire top part is 10 and 2x's. Okay, let's try that same logic for the sides. If this is 5 from here to here, then you know that this width is x, and this width is x. then shouldn't that mean that the side is 5 plus 2x's? Okay, so I'm actually going to need a little bit more room. Let's just move everything over a little bit. There we go. Okay, the area of just the mat. Now, in order to get just the mat, you need to take the entire area, so your length and your width, multiply them together. 10 plus 2x, whoops, and 5 plus 2x. Now again, that's the entire thing. We got to subtract the middle. And the middle was 10 and 5, so the area of the middle. Okay, so there's our equation. Let's start figuring it out. So I'm just going to simplify by expanding. I'm going to do FOIL. Okay, so 50 plus 20x plus 10x plus 4x squared minus 50 equals to 2 times 10 times 5. That's going to give me 100. Okay. Let's start collecting like terms. So I'm going to start doing this all in black now. Why don't we put it in order as well? So 4x squared is going to go first because it has the x squared. 20x and 10x, that's 30x. And the 50s cancel out. So then we still have equals to and that 100 at the back. Okay, so we can't solve for x. Remember, our golden rule was it has to equal to 0 on one side. So there we go. Move the 100 over. 4x squared plus 30x minus 100 equals to 0. Okay. All right. Before we start factoring, it looks like I could do decomposition because I have the a value as something other than 1. But I'm thinking, you know what? Let's just break it down a little bit by doing a greatest common factor. Maybe it'll actually make the numbers a little bit smaller. 2. Okay, what's left is a 2x squared plus 15x minus 50. Okay. All right. So I still have to do decomposition, or I can do guess and check. And just for time's sake, you can do decomposition if you'd prefer, but I'm just going to do guess and check. That's one that I like better. It's actually a little bit easier. Okay, so two numbers that need to multiply to the 2x squared. I'm going to say it's 2x and x. And then I'm going to guess, let me think, two numbers that multiply to negative 50 are 10 and 5. So again, I'm just guessing. And with practice, you do this a little bit better each time. Now I want a negative 50. So one has to be a positive, one has to be a negative. We're going to go positive here and negative here. Okay, so let's just check it out. F for first, 2x squared. O for outside, 20x. I for inside, negative 5x. And L for last, negative 50. And perfect, that makes that positive 15, which is what I want. Okay, so that was just my check. And lastly, let's solve for the x-intercepts. So again, from this case, I'm going to get x equals to opposite of this guy over the one in front of the x. So that's one of my x-intercepts. The other one will be x equals to negative 10. Thinking back to what this question was actually talking about, well, I mean, weren't they talking about the width of a frame? This one doesn't make any sense. Negative 10, there's no such thing as negative 10 measurements. Therefore, you know that the width is 2.5, and I forget if they were talking about centimeters. They were talking about centimeters. Okay, so centimeters. All right, now the reason why I changed it to a decimal is because it'd be really weird to say the width is 5 over 2 centimeters. No one says that. Okay, so this is solving quadratics by factoring. And again, the next tutorial will be covering the quadratic formula.